Okay, Assalamualaikum. Morning, guys. So, for today, we'll stay in chapter 2, analysis and design, but we will go to design of column. Okay, so for your syllabus, we will design short column. Actually, we have two types of column, short and slender column. Okay, so your learning outcomes, okay, you have to know how to describe the differences between short and slender column. Means we will differentiate between short and slender column, and you have to describe the differences between braced and unbraced column. For each short and slender column, actually, the column can be braced or can be unbraced. Okay. Then for C, D, E, and F already covered in the tutorial. Okay. So for this lecture session, we will go to the theory only. Okay. So okay, as you can see here, we have actually this one is what we call slender column. Column langsing, tiang langsing or tiang tinggi. Okay, kalau kita tengok apa dia tinggi kan. This one is kita kata circular column. Column bulat, tiang bulat. Okay, so column actually is a vertical structure element. Dia structure element yang bentuk tegak. Okay, vertical structure element or also known as vertical compression member, which is very important element in the reinforced concrete structure. So as we know, column support load from beam. Okay, then the column will transfer all the load from the top to the foundation safely. Okay, so this one is a column cross section. Okay, column cross section. As you can see here, we have a slender column. We have a slender column here. Slender column here. So from the top view, you can see the cross section of column here. Okay, so when you are asked to sketch cross section of column, this one you have to draw. Okay, so we will design square column only. Okay, square column segi empat. Tiang segi empat sama. Okay, square column only. So for sketching cross section, you just draw the square shape and label the width and also the depth of the column. And okay, as you can see, the black one, we have four main bar, four reinforcement bar, four rebar. Okay, so minimum bar. Okay, guys, minimum bar. Okay, minimum bar for column four. Okay, minimum bar for column four. Paling sikit rebar untuk column mesti ada empat. And surrounding of the surrounding of the rebar is link. Here is link. Okay, link. Link or shear reinforcement or stirrup. Ikutlah which one can be. Okay, so link, shear reinforcement, stirrup. And at the end of one, okay, at the end of one corner, here we bend the link actually. Here you can see, okay, we bend the link actually. What for? So that the link stay at their location. Okay, so here is the concrete cover. Okay, so this is the cross section of column. Okay, now we go to types of column. As I told just now, we have two types of column, short column and slender column. Short column is tiang pendek, slender or long column is tiang tinggi ataupun tiang langsing. Okay, how to identify that is short or slender column? It based on the ratio of effective length to lateral dimension to least lateral dimension. Um, okay, so short column. Okay, short column categorized when the ratio of effective length, okay, effective length, LEF, effective length ratio of effective length to its least lateral dimension, either B or D, either width or depth is less or equal to 12. Maksudnya kat sini kalau nisbah panjang berkesan dia kepada nilai lebar ataupun width or depth, lebar ataupun kedalaman kurang atau sama dengan 12. That one is short column. You just know the theory yang ni. Kita tak buat calculation for this. Okay. Maksudnya kalau effective length, ratio of effective length to least lateral dimension less than or equal to 12, that one is short column. While when the ratio of effective length to its least lateral dimension is greater than 12, we call it as slender column. Okay. Contoh macam kat sini. So yang kata tadi effective length adalah kedalaman berkesan. Okay, yang tu kita tak kira guys. So kalau kita tengok kat sini permukaan atas dia. Okay, kita tengok cross section dia, permukaan atas dia. Okay, permukaan atas dia. So kalaulah ratio effective length dia, ratio of effective length kepada dia punya D or B, okay, less than or equal to 12, that one is short column. Okay, so kita tengok dia punya permukaan atas dia lagi besar. Okay, kalau tiang pendek ni short column ni dia punya cross section dia luas. Okay, cross section dia luas. Berbanding dengan slender column, dia punya cross section atas ni kecil. Dia punya cross section kecil berbanding dengan dia punya ketinggian. Ni yang kita kata tadi, dia punya effective length kalau bahagikan dengan D dia, dia lebih besar daripada 12. Sebab D dia kecil. Okay, D dia kecil. Permukaan atas dia tu kecil. Okay, you just know the theory je. Okay, so how to differentiate between short and slender column? Again, kita tengok how to differentiate short and slender column dari segi dia punya ratio. Okay, dari segi dia punya ratio of effective length to its lateral dimension. Okay, then lateral dimension very large when compared to its length. Macam saya kata tadi, cross section untuk short column, okay, cross section untuk short column dia lebih besar berbanding dia punya ketinggian. Berbanding dia punya ketinggian. Okay, kalau lateral dimension untuk slender column, lateral dimension very small when compared to its length. So maksud dia cross section dia kecil dia. Dia tak lebar. Okay, berbanding. So kita tengok kalau tiang tu dia punya cross section kecil tapi dia tinggi. That one is slender column. Even kalau kita tak calculate pun kita boleh nampak actually. And short column generally fails by crushing. Crushing ni maksud dia kalau short column kita compress dia, kita apply load on the short column, it will crush. Dia akan patah terus. Okay, dia akan patah terus. Tetapi kalau slender column generally fails by buckling. Kalau you ingat, kita buat buckling test. So buckling test tu kalau kalau you boleh imagine slender column tu macam spesimen yang kita gunakan untuk buckling test. Dia punya cross section dia, okay, permukaan atas dia, cross section dia kecil, nipis je. Tapi dia panjang. So that one is slender specimen. Kita kata slender column. So dia punya fails dia tu adalah by buckling mode. Dia akan buckle. Sebab apa? Kalau slender column ni kita compress dia, it will buckle. Dia tak akan patah terus. Dia akan buckle dulu. Dia akan melengkung dulu. Tapi kalau short column, sebab dia pendek, so once we compress it, dia akan crush, dia akan patah. Okay, dia akan patah. Okay, so short column is subjected to compressive stress. Okay, compressive stress, but long column or slender column is subjected to buckling stress. And buckling tendency for short column is very low. Betul lah tadi kan, short column kata kalau kita compress dia, kalau kita compress short column, it will crush, dia akan patah terus. So, it tendency to buckle is low lah, dia tak boleh nak buckle. Tapi, tendency of slender column to buckle is very high. So, it's very easy to buckle berbanding dengan slender column. Ingat kita buat buckling test, kita gunakan slender specimen, so it's easy to buckle. Even kita letak kata load sikit pun dia dah easy to buckle, senang. So actually short column will carry more load. Okay, will carry more load. Berbeza dengan slender column, load carrying capacity is less. Sebab apa? Short column, dia punya area di atas ni, dia punya cross section ni luas. So, dia boleh support banyak load. Berbanding dengan slender column, dia punya cross section kecil. So, dia tak boleh support load yang banyak. Sebab it's very easy to buckle. Tapi kalau short column, even kat sini dia kata it generally fails by crushing. Tapi kita adalah method how to prevent the failure from occur. Okay. So ini differences between short and slender column. You have to know all these 6 differences. Okay. So here we see types of failure column. Tadi kita kata short column very easy to crush. Okay, very easy to crush. While the slender column is easy to buckle. When the cross section large as compared to its height, it's first due to crushing of column material for short column. While for slender column, when the cross section small as compared to its height. See, dia punya wide and besar dia punya permukaan dia. So, dia boleh support banyak beban. Jadi, tapi dia mudah patah. Kalau exceed the limit lah, exceed the limit of the column lah, so that it will easy to crush. But untuk slender column pula, dia punya permukaan tadi saya kata, dia kecil. Permukaan dia kecil. Jadi, it comes with still more load and it's easy to buckle. Dia bend. Dia tak crush, dia bend dulu. Okay? Okay, next. For short and slender column, actually we have braced and unbraced. Brace and unbrace ni brace ni macam disangga, disokong. Okay, disokong. Kalau kata tianggul kan. Tianggul, kita ada pacak tianggul macam ni kan. Okay. Kita rasa macam dia tak balance. Kan, sebab ada 2 batang tiang saja kan. So, kita buat kat dia bracing. Kita buat bracing dekat kolom ni. So this one kita panggil brace column. Sebab apa? Kolom ni di-brace, disangga, disokong oleh bracing. Okay. So under brace and unbrace ni kita ada brace column dan juga unbrace column. Okay, apa maksud brace column ni? A column may be considered braced if the lateral loads due to wind, for example, are resisted by shear walls or some other form of bracing rather than by the column. Okey, kita tengok brace column. Okey, brace column ni maksud dia tiang disangga. Okey. Contoh kat sini, dia kata brace column in Y direction. Ni. Brace column in Y direction. Okey, you tengok sini column. Ni kolom ni, yang kat tengah ni, yang square shape ni semua kolom. Okay, yang ni semua kolom. Okay, ni semua kolom. Daripada paksi Y yang tegak ni, kat sini kita ada shear wall. Sini kita ada shear wall. So, from Y axis, kolom ni kita identify as brace column. Sebab apanya? Kalau kita ada lateral force kat sini, kita ada wind force kat sini. Kalau kita ada wind force kat sini yang akan support the wind force adalah this shear wall. Dia bukan direct kena pada kolom. Because kita ada shear wall ni bertindak untuk kata halang wind force ni daripada effect the column. So kat sini dia kata tadi a column may be considered braced if the lateral loads due to wind, for example, are resisted by the shear wall. So yang column ni daripada paksi Y, kita kata dia adalah brace column. Okey, kita katakan dia adalah brace column. Okey, tapi kalaulah kata angin tu wind force daripada sini. daripada faksi X. Sini faksi X kan. Ni daripada faksi X. So there is no shear here. There is no shear wall here. Okay, there is no shear wall here. So wind force ni akan directly acted upon the column. Ini kita kata daripada faksi X ni, kita kata this column, okay, daripada faksi X, this column are unbraced column. Okay, a column may be considered to be unbraced if the lateral loads are resisted by the sway action of the column. So from the x-axis, actually the column will resist the wind force by itself. Dia tak ada shear wall dah yang nak sekat daripada wind force tu daripada kena dia. Okay, so from y-axis, this column is braced. From x-axis, this column are unbraced. Boleh nak? Macam saya bagi contoh triangle tadi. So kita boleh katakan this one is a braced frame. Sebab apa? This column are supported by this brace. This bracing. Okay. So unbraced frame, kalau triangle tu lah free. Macam triangle yang ada kat padang kita tu memang free. So actually kalau kita bayangkan, it's very easy to sway. Kalau ada angin, ni kita kata wind force. Kalau acted to the triangle tadi, okay, triangle tadi, so it very easy to sway kalau dia tak ada bracing. So kalau dia ada bracing, dia kata as support, okay, to make the this column become stable, more stable. Okay. Okay, mari kita tengok differences between braced and unbraced column. So braced column, dia ulang balik tadi je. Braced column is treated as braced in a specific plane when lateral strength of the structure as a whole is arranged with wall or bracing. Ingat tadi yang faksi Y tadi, daripada faksi Y kita ada shear wall or kita ada bracing. Kan, untuk orang kata make the column become more stable. Unbraced column pula when the lateral strength of the structure as a whole is arranged with column only. Kalau unbraced column from the x-axis tadi, kalau kita tengok from the x-axis tadi, no more structure here to prevent the wind force from acted to the column. So for unbraced column, actually the column will cover all the environmental force yang bertindak kat atas dia. Okay. So braced column can withstand lateral load. Okay. Braced column can withstand lateral load. Okay. Kenapa kita buat column yang ada ni, kata-kata column ni tadi, ni column. Okay. So kenapa column tu kita buat bracing kat dia? Kenapa kita buat bracing kat dia? Sebab dia cannot withstand lateral load. Kita tahu kalau kawasan tu adalah kawasan yang angin dia kuat, so dia mudah, kan orang kata mudah efek pada wind force, so kita tak bracing kat dia. So kenapa kita tak bracing dekat dia? Sebab dia cannot withstand the lateral load. That's why kita jadikan dia braced column. Tapi kalau kata unbraced column, kenapa tak perlu kita letak bracing dekat dia? Sebab it can withstand lateral load. Maksud dia structure column kita tu kuat lah. Structure column kita tu kuat. So tak perlu dah letak bracing ke, tak perlu dah letak shear wall dekat dia. So it can withstand the lateral load by itself. Okay. Okay, in brace, untuk brace column lagi, in brace frame, lateral load like wind, earthquake, etc. are resisted by some special arrangement like shear wall, bracing or special support. Hence, the column size can be optimized. Okay, samalah tadi. Dia cerita balik je ni. In unbraced frame, lateral load like wind, earthquake, etc. are resisted by column or which makes column heavy and large size. So, sebab dia tak ada bracing, so untuk unbraced column, kita kena make sure dia punya size lebih besar lah. Lebih besar, lebih kuat. Sebab dia akan support the lateral load by itself. Okay, brace column have zero value of sway. Of course lah, kan tentu sekali lah. Sebab kita letak brace kat dia, kita letak show wall dekat dia. So, column ni dia tak akan effect sway. Dia tak akan sway. Tapi, brace column easy to sway. Easy to sway, subjected to sway. Okay, structural system having bracing are mostly used in important spatial structures, high-rise building, communication towers, whether it is much scale. Okay, yang ni kita tengok kalau brace column ni kita tengok contoh tangki air. Okay, water tank. You tengok stand of the water tank tu, dia adalah kerangka besi. Dia ada bracing, kan dia bersilang banyak kan. Samalah juga communication towers ni. Kalau kita tengok communication towers kita, memang dia adalah apa? Kan communication towers kita bentuk triangle tu, dia banyak bracing for kita kata for skyscraper structure. For skyscraper structure memang kena ada bracing. Okay. Dan untuk unbraced column, structure system without bracing are mostly used in normal low-rise structure. Normal low-rise structure kalau kita buat struktur yang kurang risiko kepada sway, so kita buat unbraced column. No need to brace it. No need to construct shear wall for it. Okay, so brace column mainly used to design the steel structure. So kalau kata kita buat steel structure like like communication towers tadi or water tank punya tower tadi, so kita make from steel structure, so kita buat brace column. And for unbraced column mainly used to design the reinforced concrete structure. Reinforced concrete structure. Okay, sikit info untuk reinforcement details. Okay, kita tahu tadi, saya kata tadi minimum bar untuk column. Okay, minimum bar for column is 4. 4 for rectangular or square. For rectangular or square column, the minimum bar required is 4. But for circular column, the minimum bar required is 6. Untuk column bulat, minimum bar is 6. And size of bar should not less than 12 mm. Means bila you calculate, you dapat diameter. Okay, you dapat diameter dia. Bila you calculate, you dapat diameter 10 mm. Okay, dapat diameter 10 mm. So, you cannot use diameter 10. You should use 12. Okay, so your final answer should be 4. Okay, 4 number of bar. H, types of steel, high tensile steel. And size is 12. Even you calculate, you get 10 mm, but minimum size of bar required is 12. So put it as 4H12. Okay. Then for link, okay, remember surrounding the reinforcement bar, we have link, right? So how to get the size of link? Okay, size of link is quarter of size rebar. For example, you get the size of rebar is 12. So link. Okay, so diameter of link. So diameter of link equal to 1/4 times diameter of rebar. Okay, diameter of rebar. So you get 3, right? You get 3 mm. So this 3 mm is less than 6. Okay, less than 6. So you cannot use 3 because of what? The size of rebar that have in market pun start from 6, 6, 8, 10, 12, 16, 20, 25, 30, 32. Okay, so 3 tak ada pun. So let's say you dapat diameter link less than 3, you memang kena guna 6. Okay, the minimum size of link is 6 mm. Boleh guys nak? Maksud dia kalau you dapat kurang daripada 6, you kena guna 6. Sebab size dekat market pun memang yang paling kecil pun 6. Okay. So maximum spacing in column. Okay, maximum spacing ni apa maksud dia pula? Kan kita ada kolom. Ni kolom kita. Ini kolom. Okay. Lepas tu ni kita punya main bar. Sorry. Ni kita punya main bar. Okay. Ni kita punya main bar. Lepas tu kita ada link. Link kita kalau apa pula? Sekejap. Okay. Ni kita ada link. So link kat atas ni. Link kat atas ni. Kat sini. Link kat sini kan. Okay. So apa maksud spacing ni pula? Kita nak cari apa untuk spacing ni? Spacing ni actually kita nak cari ni. Ni jarak sini. Jarak. Okay. The distance between two link. Ni spacing. Tadi kita dah tahu size link. Lepas tu kita nak tahu pula berapa jarak kita nak susun dia tu. So, macam mana nak tahu? You kena pilih antara tiga ni. Maximum spacing in column should not exceed. Okay, should not exceed 20 times the diameter of the smallest longitudinal bar. So, maksud dia kat sini, yang ni maksud dia 20 kali diameter bar. Kalau tadi kata diameter bar you 12, so 20 kali 12 lah. 20 kali 12, you dapat 360. Okay. Ataupun the lesser cross-sectional dimension of column. Ni tengok dimension column. Dimension column berapa? Kalau dimension column tu dia bagi 350, 350. Okay, 350. Okay. Lepas tu 400. Dia tak boleh ni. Should not exceed. Tidak boleh melebihi antara ketiga-tiga ni. Yang paling besar 400 lah. Okay. So, yang mana kita nak pakai? Kita ambil yang paling kecil. Should not exceed. Okay. So, kita ambil yang paling kecil. Okay. Ni cantik. Ini adalah cross section of column. Ni. Cross section of column. So, kita ada square shape. So, you labelkan dia. Width dia berapa? Kalau kata tadi width dia 350. You tulis kat atas ni 350. So, kita ada depth dia also 350. Dan kita ada link. Label. Kita ada link. Okay, link tadi kalau kata kita dapat size kita tadi 6 kan? Okay. 6 H dash jarak dia berapa? Tadi kita dapat 350 center to center. 6H ni kita pakai diameter 6, jenis high tensile steel, jarak antara link ke link adalah 350 center to center of link. And rebar berapa size dia? Kita ada 4H12. Okay, ini cara you nak sketch cross section of column. Boleh guys? Ini complete. Cross section column ni complete. Okay, ini untuk round spiral column. Kita tak cover yang ni. Kita just buat untuk square short column. Okay, square short column. Ini dalam bentuk 3D lah. Ini dalam bentuk 3D. You see? At one corner, kita akan bend the link. Kita akan bend the link supaya dia maintain kat situ. Kat tempat dia. Okay. I think that's all for theory for short column. Okay. Thank you guys. Bye. Assalamualaikum.